Get ready because the shipping industry is ripe for disruption. You're listening to Autonomous Ships Headquarters Podcast with your host, JP.
Everybody, welcome to Autonomous Ships Headquarters Podcast. The goal of this podcast is to introduce to you people and companies behind digital revolution that is transforming the shipping industry. I'm your host, Juraj Pavlica, or more easily just JP, and today's guest is David Woudenberg. David is working and living in Amsterdam, and he's a true expert in applied AI across multiple industries. He's a technical lead for the company called Shipping Technology. Now, the story behind this amazing company is not the usual one, and therefore I'm sure you're gonna like this episode. The Shipping Technology is actually a joint venture between leading Dutch AI company called Xomnia and a very experienced Dutch inland shipping company called Shipping Factory. After they joined forces, very soon their first product called Black Box Pro hit the market. David is gonna tell you all about it, so without further ado, meet David Woudenberg. Hello, David. Welcome to the show.
Hi, thanks for having me.
Yeah. Why don't you, for beginning, tell us a little bit about you and how you ended up here where you are?
Yeah, so my name is David Woudenberg. I have a background in artificial intelligence as far as studies go. I was born and raised in Amsterdam. And right now I'm working at a big data company called Xomnia, based in Amsterdam as well, where we built the first self-driving boat, which we'll talk about later, I guess. Mm-hmm. And now on behalf of Xomnia, I am the technical lead at Shipping Technology, which is a joint venture of ours. And also a lot more about that later in the talk, I guess.
Yeah, indeed. But let's start with what was your motivation to specialize in artificial intelligence? Because I guess somewhere around 2010, when you did this, there was not a lot of hype as it is today about AI.
So 2010 I graduated high school, and of course I didn't really know what to do. So I ended up studying some general first year of studies, and through that I heard a little bit about AI, and what I found very appealing about it is that you use very abstract mathematical methods to solve real world issues. And through machine learning or other optimization methods, you can really solve a lot of different problems out there. And I thought, well, that's nice because you can solve problems, but also you get to see a lot of a wide variety of fields from a very specialized background. So that's why I chose to specialize in AI.
Interesting. And I mean, AI is quite a broad term.
Yes.
Do you have like a special field?
Well, most people nowadays think artificial intelligence is only machine learning. And that's also my specialization from the university. So I specialized in machine learning and also quite a bit into deep neural networks. What the whole hype cycle is about right now.
Yeah, indeed. That's true. And so you're employing all of these knowledge at Xomnia?
Yes.
How did you end up there?
Well, to tell the truth, I just got recruited. So I was fresh out of college. And looking around for what I'm going to do now, and I thought, well, data science sounds cool. And somebody from Xomnia got in touch with me through LinkedIn, and I went over to their office the next day, and a day later, I basically had a job there.
Wow, sounds cool.
Yeah, it's a tough life.
Yeah, tough life. Good headhunting on their side. And you're lead autonomous and also technical lead there. So what exactly do you do? Do you only focus on sailing autonomy or also some other industries?
So our main focus is sailing autonomy, and also my main focus at the moment is shipping technology. But at Xomnia we also have a couple of other research projects based on our self-driving boat, and one of them is a pilot where we use the simulator of the trains of the Dutch railway services, and we used reinforcement learning to see if we could get an artificial intelligent agent to control this train basically without ever teaching it how to do, but just letting it learn by trial and error.
Interesting.
And we got some interesting results. So in the simulator, we got about, I don't know the exact number, so don't pin me down, but there was quite a big efficiency gain in terms of energy usage.
Wow, that sounds super interesting.
Yes.
So we hope in the future to see some of those applications reach the surface.
Well, who knows?
I also saw on the websites that recently you presented some of your work in UN office in Geneva. Can you tell us a bit more about it?
Yeah, that's true. We were there. So I guess not many people out there are working on autonomous shipping or autonomous vessels. They were having a conference at the UN about what did they call it? The fourth industrial revolution. So blockchain, AI, autonomous things. I think that was the exact same wording as they had on their website. Mm-hmm. And they wanted somebody to talk about autonomous boats, and they Googled and they came out to our company. So we went there, and it was UN is a big organization, and they deal with big, vague problems. So also all their talks are quite vague and on a meta level. Mm-hmm. So it was quite cool to present our really applied case that we had at that conference.
Exactly. That's a good segue to our more geeky and down to earth part of things. So yes. Let's start with this self-driving boat. So as I understood, it all started as an old lifeboat, which ended up being an electrically propelled autonomous boat. So how did the idea for self-driving boat came to being?
Xomnia is based in the center of Amsterdam, like right on the canals. And we already had a small boat which we could take out on a Friday afternoon for drinks and just to relax and have some fun. Mm-hmm. But Xomnia was growing quite rapidly, and the boat became too small. So the company decided to buy a bigger boat, and they bought this old life vessel, which used to hang off the side of an oil rig. And they, basically what they do is they take off the top and they give it to yuppies in Amsterdam, and they say good luck. But these boats are not very easy to control. And one of the first times that Xomnia took out the boat together with a couple of business partners, so basically clients of ours, they came into a notorious crossing, which is just outside of our office actually. And I think they collided with 3 other boats.
Oh, wow.
And then also like the authorities came by and said like, what do you think you're doing? So then at first it was a bit of a joke. Like, okay, we have all these smart people doing stuff with artificial intelligence, and we have this boat. Why don't we make a self-driving boat? But that idea became more concrete, and even more so because there was a student, a computer science student, who approached us, and he said, well, I want to do a graduation project, and I want you to give me an assignment which is impossible. So, naturally, we came to our self-driving boat, and he took it from there.
Wow, that's a super interesting story. Mm-hmm. So it ended up basically being a fully functional self-driving boat. And,
no, let's not call it like that. No? It was a very good, it was interesting achievements that we had. It was not fully autonomous self-driving, but the first steps were definitely there. So what we did is we used what we call an end-to-end learning approach, where we collected data, and basically we said, well, we need to collect all the inputs for the captain. So what does he see around him? So we placed webcams all around the boat, and we need to record what is the captain doing. So basically the electrical pods, they have a certain voltage being sent to them, and we recorded that voltage every time. So we had a data set consisting of images, so that's the context, and the voltages, so that's the actions. And we trained a neural network to correlate these images to these actions. And then we let that trained network actually control the boat. So it would analyze the pictures coming in, and then it would predict, as we say, voltage values to these electric pods. and in that way control the boat.
Wow. So that's real end-to-end
Yes.
end-to-end approach.
Imitation learning is also called.
Yeah. And so imitation or behavioral cloning, I found somewhere. But that's basically the idea. But it sounds quite quite a severe departure from usual robotics approach, where there's much more sensors, much more processing power needed,
and much more modular. So there is upsides and downsides to this approach. An upside is that just by collecting data and training that model, you can have results where you have something that is autonomous up to a certain extent. A downside is obviously these neural networks are like black boxes. You don't really know what's going on inside of these models, and if it makes a mistake, you really don't know exactly why. So in that sense, it's harder to control, let's say, by a human to control the sort of workings of the model.
Yeah, but a human is always there to overtake the control.
Yeah. So in the setup we had a big red kill switch, which we pressed multiple times while testing.
It's how it starts.
Yes, exactly.
And how did you train your networks? How did the whole training process go?
As you train neural networks, so mini batch updates, updating the weights using gradient descent, where we would try to predict basically the actions of the captain based on the context. So we would like to get those predictions as close to the truth as possible.
And on your website, there is also a white paper available describing this. So I urge to listeners also to go there and download it and to learn in details.
Yeah, that's at somnia.com, and you can find the white paper somewhere there.
One of the things which I didn't understand from reading that white paper is you said that you needed to prune your sailing data from straight sailing parts.
Yeah, so we have a big problem, which is imbalanced data, as we call it. So we have a lot of data points or a lot of instances where we're just sailing straight ahead. And compared to that, we only have a very small portion of data where we are actually making turns. There's multiple ways to battle it, but we were looking to go sort of ahead quickly, and then the quickest option is just to take out a set of the straight sailing part, so that your training or that your target data is more or less distributed normally. So we just sort of cut off the top.
I get it. And your training route through the canals, was it something specific you defined? You tried to make it diverse as much as possible with tunnels, with crowded parts, with sharp and easy corners.
So we started off with just everything. Which soon we discovered, we need to have our first proof of concept and really give it like a showcase. We need to concentrate more on like one little tour. So we did both, but we found that, of course, if you focus on a small area, you overfit on that route, or you can really focus your network to really learn that route specifically, and you need less training data total to have something to show for. So in the end, we ended up going for a specific training route.
Okay, makes sense. And for feature extraction, you used convolutional neural networks. That's like on top of your software stack. How did you do it? I mean, was it supervised, unsupervised learning? Or?
Yeah, so it was all end-to-end. So it was literally on the input side, you put in images from the webcams, and on the output side, you get these voltage values. So it's supervised learning in that sense. And it's all end-to-end. So the feature extraction is something that happens implicitly.
Implicitly inside.
We don't explicitly try to learn to recognize other ships, or to recognize swimmers, or to recognize bridge pillars, or any sort of things like that. Everything that the model learns about that is being done implicitly.
And as a last point for this self-driving boat, Could you explain us a little bit the interpreter? Because I found that as a kind of most important part of the...
Yeah, this is something we only really trained in simulation. But this is something that was sort of an idea for a way to do route planning in an end-to-end setting, where we would have a second network which would recognize whether or not there was an intersection, and then we would have a route list. So basically we would know at the first intersection go left, at the third intersection go right. So in that way we could do route planning, but still have sort of this end-to-end network controlling the normal behavior of the boat.
Okay, so the interpreter was the one who would once come into when the boat comes to the junction would choose, okay, at this point I need to go left, for example.
Yes.
All right, nice. So you guys successfully hacked this self-driving boat, and
well, some encouraging results.
Yeah, and at some point, Exomnia, which is a prominent AI company, joined forces with an experienced maritime company called the Shipping Factory. And as I understood, the new joint venture was formed called Shipping Technology.
Well, not straight away. Our lifeboat that we started on, it needed to have quite some modifications done. We needed electric pods. We needed to update the way we could steer the boats, etc., etc. And this does not come cheap. And actually, we went looking for sponsors to help us out with financing the whole project. And well, we had quite a number of sponsors, but one of them was Shipping Factory. Well, the owner, Remco of Shipping Factory, actually went along on a couple of the first test runs on our self-driving boat, together with his father, and they were very enthusiastic. So these are people who have been sailing big inland shipping barges for all their life. And Remco was is looking for ways to sort of, well, innovate and mostly to see how can we as an inland shipping world become autonomous. And he was doing like a couple of projects and pilots with partners from inland shipping domain. So people who are already working in that industry for quite a while. But he can be quite an impatient man also, and he thought, well, this is just taking way too long. And he saw the results that we were having with this end-to-end approach from just a couple of hours of data. And well, I think the project was like 6 months old at the time, and he thought the results were really encouraging. That it's that in a short amount of time you can really make good steps towards autonomous shipping. And he said, well, I want you to continue this project, but I want you to continue on one of my ships. And well, one of the big upsides about using there's a couple of big upsides about using one of Remco's ships. And I think one of them is that the ship is always operational. So with our own boat, we had to take it out and go boating around the canals of Amsterdam, which is it's not a punishment. I mean, it's pretty nice. But if you're also you have to work and you have to keep the company going as well. It's just a lot of valuable time that goes into collecting data.
Sure.
Where for this ship, they have to sail anyway. Another big upside about using one of these big professional vessels is that they already have a lot of sensors and equipment that the captain is using to navigate, which we can actually collect data from quite easily. So on our own boats, well, if you're sailing the canals of Amsterdam, what you do is look around. If you're sailing a big inland barge, I believe Remco's is like 135 meter long. Of course, you do rely a little bit on sight, but one of the most important inputs is your radar. And next to that, you also have inland navigation charts, and as a captain you know where you are, so you know where the area around you looks like, and you have depth sensors which you look at to see how much water you have between the boats and the bottom of the river. You have immersion sensors, so it tells you a lot about the heaviness of the load of the boat, of the cargo. And of course, if the cargo is a lot heavier, then you can see that the ship will behave differently. And then there's a whole range of other sort of sensory data that is already installed on all these ships, and the captain uses it to navigate. So I think the amount of contextual information that we can get from an inland ship is a lot larger than from our little boats on the canals. And the fact that we can collect data all the time because it's operational all the time. Those are the two big upsides of working together, or of moving from a boat to a inland shipping vessel.
So that was the next step. Next step was to put this developed technology, expand a little bit more, hook it up to the inland container vessel.
So of course there was some challenge in getting this data from all these sensors, but what we did was we placed the computer in the Factor 4, which is the ship which we're piloting on, basically. And we used we worked together with a couple of other companies, Alphatron mostly, sell nautical equipment, so they sell the radars and all the depth sensors and all that stuff, and they helped us with getting all of this. Well, it's not per se that this data is not digital, but they helped us with interfacing with these all these range of sensors and getting that data into our machine. So the engine and also the bow thruster. So again, we would have all the context that the captain has, together with the actions that the captain takes. And we tried to, or actually we did, we tried the same approach, where we would have an end-to-end model, which takes, all of this context and tries to predict the actions of the captain. And then also in cooperation with Alphatron, we built a second system to also be able to control the ship with a computer, basically. So completely parallel, there's a system parallel to like the normal control of the vessel. There is a system which we can digitally send commands to rudders, engine, and bow thruster to actually control this vessel digitally. And we have done one test where we had a end-to-end model which was trained on a couple of weeks of data, and it would actually read from the sensors live and then predict what the actions of the captain should be, and it would send those predictions as commands to the components I was talking about earlier. So in our test, we only controlled the pilot, and the test was mostly focused on testing this whole pipeline where data comes in through the radar, it gets sent to our computer, the computer analyzes it, makes a prediction, the prediction gets sent over and controls the vessel. And so the whole pipeline worked, so it was a successful test. But this simple model, the first model we tested, it also showed behavior that you could compare to a very novice captain. So it was making okay decisions, but it was also moving the rudders quite a lot. And what I have learned from the past year and a half in dealing with or talking to captains is that captains always try to minimize the amount of steering movements they make.
Yes, exactly. So it's wear and tear on one side. I mean, there's also a similar approach there is in dynamic positioning in DB computers. You also have a mode probably to minimize the amount of thruster movements. But for the beginning, it sounds amazing. It sounds that you're really onto something good. Of course, it needs some polishing, but
it obviously needs a lot of polishing, and there's a lot of questions that we have still, and a lot of things we need to figure out. But the results so far have been encouraging on a lot of sides. So I think that's pretty cool.
Indeed. Did you need to acquire some special permits from authorities to do this or not?
Well, once again, as we did when we were testing with our little small boat on the canals of Amsterdam, we had a very ugly red button installed in the steerhouse, also if the captain would touch any of its normal controls, then the system would switch back to conventional steering mode, and we had a captain in the seat all the way. So we are convinced that we were a lot safer than normal operation, and also we did have a testing protocol set up, which we talked about with our insurer, or actually the insurer of Shipping Factory, and they approved of it. So we were covered in our sense, and also we thought we were doing it quite safe and controlled.
All right. And was there a special location where these tests are permitted in the Dutch inland waterways, or not? Or it was just the usual route of the ship?
We used the usual route of the ship. I know Rijkswaterstaat, so that's the Dutch authorities for the waterways. They might have some like special locations, but we used a part of the route where the water is very, very broad. And the weather conditions were very quiet. I think this was the best place to do this test.
Yeah, where the risks are minimal.
Yeah.
All right. How did your commercial product then came into picture, the Black Box Pro?
Yeah. So we were having these tests and developments, and we saw a couple of things. So first of all, we were collecting data from one ship, which is operational all the time, which is very nice. But if you also look at autonomous vehicles, cars, you see Google has been working on one autonomous car for, the last 10 years.
Indeed.
And Tesla has been working on them for, of course, also with the knowledge learned at Google and a lot of other companies. But one of the strongest points for Tesla is that they have thousands and tens of thousands of cars on the roads collecting data all the time. We also saw that we would need to have more data for more vessels, but we also people were telling us, different ships behave in such different ways, so it will be very hard to build like a generic product that will fit on all these ships. So we thought, the only way to really know this and how this works is to collect data for more ships. So that's one thing. We really wanted to collect data for more ships. The second thing we saw is that actually the data we were collecting was already very interesting in potential. So because we have, and I think that's very unique, at least for inland shipping, for maritime this is probably already existing, is that we have a product which collects both all the context and the actions of the captain, which is what we need to train our models. But this is also exactly what an insurer would like to see at the moment that there is any sort of incident, or exactly the type of information that you would like to have to educate your crew, because a novice captain might want to compare his sort of behavior to a more experienced captain, and in this way you can say, okay, we've collected this data. If you store it in the right way, you can make these comparisons. And we also we're seeing this autonomous product which we're developing, and we are very fond of this end-to-end approach, but we also think that we will need to have a lot of checks and balances maybe, or help from the more classical robotics approach. So we would definitely like to check if the course that's chosen by the end-to-end approach, you would like to check, is that not going to collide with another ship, or even more fundamental with the side of the river. So we also saw that we would probably be able to develop products based on this data very soon. We needed more data. we thought that the data alone would be a product by itself. And we also thought, well, we can probably deliver products based on the data before we even have the autonomous product ready. And all of this will help towards the autonomous product. So we launched what we call the Black Box Pro, which is the black box was sort of a wordplay on the black box nature of our models, that you can't really look inside them. But also because it does collect all the data as a black box in the airline industry does. And we decided to call it Pro because it does not only collect data and send it to the cloud, but it also has the ability to analyze this data locally on that computer, which it is. Well, for example, warn if there's a collision impending with another ship or the side of the river.
Very interesting. And for what type of vessels is Black Box Pro designed for?
So we are focusing right now on inland shipping. So that can be container, tankers, river cruisers, bulk. Well, there's probably loads more out there. We want to be able to retrofit it to any type of vessel, but naturally it does need to have sensors of quality, and also we need to be able to interface with them easily. So we try to do it for everybody, but we see that ships that are very old, we don't want to take that challenge up. But any new vessel, we can definitely connect to it. Basically, it's a computer in a server rack configuration, and it has network interfaces, so basically just internet cables. And with those network interfaces, we can interface to the sensors using some solutions provided by installation partners of ours.
And do you interface with current nautical and engine sensors?
Yes.
But do you also need to install additional ones like cameras or not?
So we decided not to install any extra sensors yet. Our philosophy is that if the captain can make the right decisions based on the information it has right now, then we need to store the same information as the captain has to be able to reach an autonomous product. So we don't install any additional sensors, but we try to connect all of the sensors that are on board now. Right now, we are not yet collecting the maritime data, which is obviously very important because it's the communication between ships. So that's something that we want to pick up, but we first have to finish what we're working on right now before we can take up all of these other ideas.
I get it. And once you collect all of these data, I mean, it could be quite a big data sets. Is the ship owner in control of this data, and is this data transferred to the cloud? Because if it is, I mean, it sounds like a lot of data to be transferred to the cloud. And is that expensive, or how does it actually work?
Depends on what you call expensive. It's not for free. It's quite some data. We decided to not send the camera images to the cloud, which is, by the way, we don't always collect data from the cameras, only if the ship owner wants us to. So we keep the camera images in a local buffer, and we send all of the radar and all of the other sensor information, we send that to the cloud over a 4G connection. It depends a little bit how much data it is exactly, but it's a handful of gigabytes a day, to give you sort of a ballpark figure. And some days, so the radar is in terms of bytes the most amount of data, and the radar is only turned on when the ship is sailing. So you can imagine when there's days of loading and unloading, then there's less data to be sent than on days when a ship is sailing. So it depends a little bit how much data exactly. And your first question was, is the ship owner in control of his data?
Yeah.
So yes, the ship owner is the owner of the data still. The ship owner can access this data through a dashboard where we visualize part of the data. He can have have a live view of what's going on with the ship, and he can also replay data. So that's really like the first use case I was talking about.
Wow, that sounds interesting.
Yeah. So that's already it's already working right now. So a ship owner can go back in time and see, in the case of any type of event, he can go back and replay and see what was going on at that time. And naturally, he can also ask us for a dump if he needs anything like that. And we also, so that's sort of who's the owner of the data. And we can use the data so shipping technology can use all of the data to create products that are beneficiary to the inland shipping world. Mm-hmm. So we can't just go off and sell it to the Googles in this world, and we don't want to. But we do use the data to, for example, develop this collision detection tool, but also to develop this autonomous product, which is the end goal in the end.
Yeah, I get it. So besides, you said that the ship owner can see this data on the dashboard.
Yes.
Do you also process this data to give him some insights into?
Yeah. So we're still working on more advanced insights. So one thing we do show now is like the past 24 hours, what was the average speed, which is not very insightful yet. But something we also show is the last 24 hours, when was it moving and when not. So you know something about resting times maybe. And also if, for example, it hasn't been moving for quite some time, then there's probably something going on at the terminal where the ship is at that moment. Mm-hmm. Another sort of insight that we really want to develop, because we see a lot of people asking for it, is expected time of arrivals. Well, it can help terminals, it can help ship owners, it can help a lot of people. And there's no real product for that right now yet, except for the captain has some idea, well, I'm right here right now, and with these conditions, going this speed with this load, I'll be there in, say, 1.5 hours. But because we collect all this data, we can do that in a smart and data-driven way, and that's something we want to develop in the future.
Interesting. So besides having all of these nautical data mined and stored and managed, you developed a platform that is much more flexible, and it will have much more capabilities in the future. So,
yes, exactly.
So Black Box Pro can also run certain applications in C.
Sorry, can you repeat that?
Yeah, sure. So as I said, right now you're just mining data and saving it and presenting it via dashboards. But in the future, you could also run all kinds of applications on Black Box Pro. Black Box Pro.
Black Box Pro. Exactly.
Thank you. Could you tell us a little bit more about that?
Yeah, so we'll be able to run applications both on board of the ship locally and in the clouds. We really want to be able to run applications locally, because we don't want to be dependent on some connectivity issue. And the first application, and I briefly mentioned it already, is a collision detection tool. And the first version of that will be very simple. Where we know where the ship is, we know what course it's taking, and we know some other variables about the circumstances. So we can extrapolate the routes that the ship will take if there's no other actions from the captain for the next 2 minutes, say. Mm-hmm. And using that together with inland shipping charts, so we know where the fairway is, we know where the side of the river is, we know where bridge pylons are, we know where there's restricted areas. For example, in front of a weir, there's usually like a canal where you can't go in. And if you continue through that canal, then you go into the weir, and then a big disaster happens. This actually happened in the Netherlands 2 years ago. And these are all, well, because we collect that data and we know, well, you're not supposed to do it, we can give a warning to the captain to say, well, watch out. If you go on like this, there will be a collision. Maybe it's good to take some action. So what we're working on right now is figuring out the best way to interface with the captain to give the suggestion of an intervention rather than telling him he's not doing the right thing.
Mm-hmm. So situational awareness and some sort of control action advice.
Yeah, control action advice, and it really is advice. And so that's also, I think, good to mention. On the Factor 4, as I mentioned earlier, we have a way to actually control the vessel digitally. When we connect this Black Box Pro, we don't have any form of control of the ship. We won't need that at some later point when we have a autonomous product, but we don't know exactly how that will interface yet. So we didn't, and it's quite costly to make the adjustments to the ship. So we decided to just collect the data for now. But to get back to the collision detection tool, it's all happening on board of the ship. So there's no data connection necessary to generate this warning. And that's, I think, very important that you can actually, because there's all sorts of scenarios where the connection gets lost and you still want to be able to give this warning.
Exactly. Yeah. And what about security? How do you ensure that nobody but ship owner can access this data?
So we know for every data point to which ship it belongs to, and we can give access on ship level. So ship owners can only see their own data in our database. Mm-hmm. And they have a password to log into their dashboard. So if they change their password after we send them one, and they choose a strong password, they should be safe. But I think we have security covered quite well. But I think the weakest link will probably always be us humans. We advise everybody to watch out with their passwords, and they should do so always, I guess.
Indeed.
But we of course take measures to make sure that it's not easy for people who shouldn't be accessing the data to access the data.
Yeah, makes sense.
Yeah.
Makes sense. And from our previous short talk, you mentioned that the applications are built as microservices. So
they are.
Multiple applications have their own APIs, and then that's how they basically can speak with each other independently.
Yeah, that's true. So basically, on the first part of our architecture, we ingest data from different data sources. So depending on, for example, the type of radar, we can switch in a different microservice, which will produce which will uniformly produce radar data for other applications to use. And then another microservice might be dealing with the engine data, and also depending on exactly the type of engine and the interface we use to talk to the engine, we can have different applications for that. So that makes it very easy to work with. Well, every ship has its own characteristics and own configuration of equipment, so it makes it very easy to deal with that sort of challenge. And also, if we build a new application, as for example, collision detection, we will just be able to place this new application in there, which knows which data to ask for, and it knows which other applications to talk to be able to actually communicate the warnings. And in this, so it's I think becoming more and more common to build your to have your data architecture as microservices, because you sort of encapsulate and modulate your all your functionality.
Yes, indeed.
Yes.
All right. So if I would be a ship owner, I would definitely go for one. So let's say that I want one, and you need to install this on my vessel. How long does it take? And do you need to modify some of my equipment? How did the whole installation goes?
So we aim for a day, but we're learning. We have a couple installed right now, but so on the Factor 4 we took like a total of 3 or 4 days, with days in between, of course. So it was in between operations. We were really learning, and now we're really aiming for half a day to a day on board, but we sometimes see that it takes a little bit more than that, which is a challenge because, of course, these ships, when they're lying still, they don't make money, but they cost money. So as a ship owner, you want to take, and also, of course, then we want it to take as little time as possible. As far as modifications to the ship, we have to build some interfacing or install some interfacing module to interface with the normal serial data which is on board, so the GPS, depth, etc. information. And we either need to update the radar or have another module to interface with the radar. And we have we don't do that ourselves. We have installation partners, which are basically the installers of nautical equipment as you know them in the Netherlands. So Alphatron, AMS, DMT. They help us with the installation, and actually we are working towards a situation where they actually do all of the onboard work. So they install the whole thing, and we don't have to go on board of the ships ourselves.
Excellent.
Because
so the Black Box Pro is available on the market, right?
Yes, definitely. You can order one if you have a ship, and of course there are some sort of minimal requirements that we have, but it is available.
And what is the pricing model?
So there is a one-time fee for the installation, which is dependent on the configuration of your ship, and then we have a monthly subscription, which covers the data transfer, so the connectivity, the telco subscription, and also the data storage. And then all extra applications will have its own fee. So if you want to also run collision detection, you buy it from an app store. And then also there will probably be a monthly fee for that.
Okay, so it's basically one-time fee for installation, and then all of the features are basically a subscription based.
Yeah, that's the pricing model we're looking at right now. And yeah, so it might be that there will be apps that in the future that have a one-time fee, but I think most of it will be subscription based.
Sure, makes sense. Then you can provide the best service for updates and everything to your customers.
Exactly. And the idea is that the applications and the product that we provide actually add value to our customers. That really, because of this ability to look back in the data and see what happened, to be able to predict these collisions and then give warnings to the captain, that they actually see, well, with these products, I will be more efficient, I will be more safe, there will be less collisions, so it's worth my money. And in that way, we collect data, we earn a little bit of money, and we can use that money that we earn to develop new products and work towards our end goal of autonomous or semi-autonomous products for inland shipping.
Exactly. And at some point, the insurers will also see a great benefit in this, and maybe even lower the insurance fees to the vessels that have this technology installed on board.
Who knows? I think they should. Yeah. And also we hope that maybe just that it won't only help with the question of what happened, but it will also make the captain a bit more aware of his actions, because, well, he knows that he can't blame it on somebody else anymore.
Yeah, for sure. All right. And what's next for shipping technology?
Well, so right now we're really focusing on really delivering that value that I set out. So we really want to install all of these black boxes and make sure that the insights that we give really add the value that we believe it adds. And next to that, bring the collision detection application to market. So once we have the basic done there, where we just use charts to see if there's a collision with some static object, we want to also use radar images to detect where are other ships. So of course you have AIS information for that, but it's not very reliable. So we really want to use the radar for that. And in that way, really, see, okay, there's going to be a collision with another ship because we predict this path based on the radar data. And then the end goal is, as I mentioned a couple of times, to have a semi-autonomous product. And we really believe that these collision detection tools are a step in that way, so that we can we need the same information there to do the smart path planning that we need for the autonomous product.
Awesome. Sounds like a really good strategy for the future. I really hope that you guys make it.
I'm quite confident.
And for the end, why don't you tell us where can people learn more about your product and technology?
Yeah, so we have a website. It's shippingtechnology.com. There you can find ways to get in touch with us, or you can send an email to info@shippingtechnology.com. And I think that's the best way to get in touch.
All right, great. I think that's about it. So really amazing product, great joint venture, and really sounds interesting what you guys are doing.
Yeah.
And thanks, David, for this opportunity and this nice talk.
Yeah, thanks for having me.
Everybody, thank you so much for listening, and I really hope you enjoyed this one. If you haven't already, be sure to follow us on Twitter. Our handle is @AutonomousShips. You will also find us on Spotify, YouTube, and LinkedIn, so go ahead and check that out. It would mean a world to me if you would share this episode with your friends and colleagues on social media. That is our oxygen, so please don't forget to do it. Besides that, you can always give us feedback in the comments. That is very appreciated. Thank you, and until next time, my friends, take care. Oi, oi.